So, g'day guys. When we are looking at linear graphs, it's important for us to realize that the angle or the way the line is slanted has different properties depending on how it's slanted. So lines have what's called a gradient or a slope, and that gradient can be positive, negative, undefined, or it can have no gradient. Now, there is a difference between zero gradient and undefined gradient, which we will get to in a moment. But first of all, what we have over here, what we have over on my right hand, on my left, your right, is an axis. And what I've got here is, what I'm going to do here is I'm going to draw an example of a positive gradient line. All right. All right. So this is an example of a positive gradient line. It starts in quadrant 3 and goes across and up into quadrant 1. Now, obviously, it will go infinitely on in both directions. All right. It will just keep going infinitely. So it is a positive gradient because as you move right, the graph is also moving up. A negative gradient line, it does the opposite. So change colors for it. And that's a negative gradient line. Because it starts, so remember, these are our quadrants. 1, 2, 3, 4. The line is going that way or that way. So this black line is positive, and this is negative here. All right, so a positive line starts in quadrant 3 and heads towards quadrant 1. A line with negative gradient starts in quadrant 2 and heads to quadrant 4. All right, so that's one way that you can think about whether or not a line is positive or negative. All right, so a positive line, we want to go to the right and then up. But on a negative line, we go to the right and then down. That's the main way you can tell the difference between a positive or a negative gradient. A line with no gradient is simply just a flat line. All right? So, thinking about it like this. Like this green line has a gradient of 0. All right, it has 0 gradient. As it moves from left to right, it doesn't go up, it doesn't go down, it stays flat. A line with undefined gradient is a line that goes literally straight up and down. All right, it doesn't move left or right. That's why it's undefined. Gradient is about rate of change, how something changes as you move across the x-axis. But my line here, as it moves from left to right, it doesn't change. It is always that line. It doesn't change. It doesn't go left or right. It just goes straight up and straight down. That's how we know it's called undefined. There is a way to mathematically prove that it is undefined, which we'll get to in a moment. But for now, undefined is the word that we're looking for to describe that line. So Blue line, green line, black line, rainbow line. Remember those and how those are connected to each other, and that will help you remember whether or not something is positive or negative or undefined. So, if what we are sometimes required to do what we are sometimes required to do is we're sometimes required to measure the slope between 2 points on a line. Now, a gradient on a straight line is always the same. All right, it's literally written there in the equation. The number that's attached to the x, as in the coefficient of x, is related to the gradient of that line. Now, I have here I have a straight line and a flat line, because I'm going to draw a set of axes again. All right. And now what I'm going to do is I'm going to plot a couple of points around the place. So I have a black dot, a blue dot, a green dot, and a red dot. If I were to draw a straight line between the red dot and the green dot, would that be a positive or negative line? So I draw a line between the red and the green line, green dots. Would that be a positive or negative line? All right. So it is a positive line, because even though that line starts, or even though the dot is in quadrant 4, even though the line is in quadrant 4, which, is a reasonable enough thing to assume, if I draw the line and I were to keep going with that line, and it would go all the way down, eventually it crosses over this axis and into quadrant 3. So even though the line doesn't look like it goes into quadrant 3, it does if you extend that line far enough. So, and you can see there, as it keeps going, it'll just keep going and get to where we need it to get to. If I delete my line. If I am creating a line between blue and red, remember I'm going from left to right. I always think about things in terms of left to right. If I go from blue to red, is that a positive or negative line? All right, that's now a negative line. If I go from black to green, is that positive or negative? Yep, positive. Saying a lot of positives, which is good. And now, a black to red. Black to red. What sort of gradient would that have? Yeah. All right, so even though the picture, if you were to actually zoom in on it and you were to measure it, it probably would have a very, very, very negative, very, very slight negative gradient. I intended for it to be completely flat, have zero gradient. Now, one of you said undefined. That's blue to black. That is from blue to black. That is the undefined line. All right? So, if I'm measuring blue to green, that is a very, 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 very shallow, slight negative gradient. All right, so what we have is we actually have formulas to use when we're determining these things. So what I'm going to do here is I'm actually going to assign some values to what's going on here. So this is going to be -3 negative 4. This here is going to be negative 3 and 5, because it's positive 5, it's in the positives. This one here is going to be, we'll go positive 3, negative 4, because it's 3 across, 4 down. Just redraw that. And then this one here is going to be, it's going to be 4 across, because it's a bit further on from 3, and it's not as high as the 5, so it's going to be 4. So I have some rough values for where these points are, and what we're going to do is we're going to use a formula to mathematically calculate where these points are. So what you need, and I'm going to write it over here on the board, is you're going to need to use a formula which we call the gradient formula. Some of you may have seen this before. Now, some of you would know the gradient as the symbol m as being rise over run. Now, the idea is that we want to change your thinking about that. So instead of being rise over run, we want you to use an actual mathematical formula with actual numbers to help your thinking. So what we want it to become is m equals y2 minus y1 divided by x2 minus x1. So we want you to measure the change between the point on the right and the point on the left in both up and across. So up and down and across. And then that will still give you the same answer as rise over run, but having the formula will allow us to do it much more precisely, because you may be asked to do calculations where where you might be involving decimal points, it might be involving fractions, it might be involving surds, which is another type of number altogether. All right, so having the formula means that you can at least demonstrate you're working out properly, and then substitute into the calculator, which means less opportunities for you to make a mistake. Now, what we have to do is, so for example, if I am asking, let's draw a line on here. Let's connect these two here. So I'm going to put a line through there. I'm going to have my rainbow line. Good old rainbow line. Now, the line connecting it passes through +3 minus 4 and +4 plus 4. What I'm going to do is I'm going to assign a set as being x1 and y1. And generally what we do is we always assign the one on the left as being x1 and y1. And then the point on the right we assign to being called x2, y2. And now that we've assigned these values, we then put them into our formula. So in this case here, m is going to be equal to y2, 4 minus y1, which is minus 4, divided by x2, which is 4 minus x1, which is 3. And then 4 minus 4 comes out as 8. And 4 minus 3 is equal to 1. Therefore, the gradient of this line is just 8. If I were to now change my angle and I were to look at the working out to, let's connect to get the angle right. There we go. Now I'm going to connect these 2 points together. So I'm going to connect on this line here. So I'm going to go over here. All right, so someone has just asked me the question, is it going to be a problem if we get things the wrong way around? And the answer to that is no. However, it's just better for you to think about it in terms of thinking as the point on the left is always x1, y1. The point on the right is always x2, y2. If I look at my previous question and I do swap x1 and y1 around, so instead of being plus 3 minus 4, it's now plus 4 plus 4. If I swap these around, I suddenly have minus 4 minus 4 and 3 minus 4. So I simply swap the order around. Those negatives are still there, but this minus 4 goes over here, this 4 goes over here, this 3 goes over here. What is minus 8 divided by minus 1? It's still plus 8. All right? But by doing it my way, as in the one on the left is always x1 and y1, and the one on the right is always x2 and y2, you have less opportunities to make a mistake. Because if you do get it the wrong way around, you might forget to cancel out certain negatives, and all of a sudden you might end up with a negative answer instead of a positive answer. So it's about reducing opportunities to make mistakes. So let's look at this line here. We'll go over here. So I'm going to call this one x1 and y1, and this is now x2 and y2. M equals y2 minus y1 over x2 minus x1. So y2 is minus 4, y1 is minus 5, is 5, so it's minus 4 minus 5, divided by x2, which is 3, minus x1, which is minus 3. So that then comes out as m equals minus 4 minus 5, which is minus 9. 3 minus 3 minus 3 is 3 plus 3, which is 6. So that means m is equal to 9 over 6, or in actuality, simplify it down to 3 on 2, or negative 3 on 2. So this here, m equals a negative 3 on 2. So with these equations, you can now have a precise way of measuring, because your answers aren't always going to be something nice and neat. They could be, for example, as we've got up there, m equals negative 3 over 2. Now, is it always left as a fraction? It depends on what the question is asking. Sometimes the question will ask you to express your answer as a fraction. Other times will be ask you to leave it as a decimal. Generally, I like to leave these as fractions, because sometimes you might be like, well, what happens if my answer is 4 over 3? Well, 4 over 3 as a decimal is an infinite decimal. It's 1.33333333333333, and so forth. So by leaving it as a fraction, I don't have to worry about that infinite decimals. There's no rounding involved. It's just, here's the fraction, deal with it. So I'm going to... Can I get rid of that line? That line in particular? Yes, I can. Can I get rid of this line in particular? Yes, I can. Beautiful. So I'm gonna clear off a little bit of this here, because I want to do the last two examples. because these last two examples will demonstrate why some things are zero gradient and some things are undefined gradient. So let's first things first do my zero gradient line. I'll do it in blue. Again, point on the left, point on the right. X1, Y1, X2, Y2. M equals minus 4 minus 4 divided by 3 minus 3. M is equal to minus 4 minus 4, which is minus 4 plus 4, which is 0, over 6. So M is equal to 0. So it's a flat line. There is no gradient. All right, so that's when your y values don't change. So you have a 0 gradient when your y values don't change. Now, if we go over to here and we do our straight line for this one, we'll do it in green. M equals y2 minus y1 over x2 minus x1. How do I know which one's on the left? Again, doesn't matter. As long as I'm internally consistent and refer to this set as the same number, so x1 and y1, I can call this one x2, y2, no problems. So y2, so it's minus 4 minus y1, which is 5, divided by minus 3 minus 3. So that's minus 9 divided by, what's minus 3? Plus 3. Therefore, that's minus 3 plus 3, which is what's minus 3 plus 3? 0. And what happens if you try and divide by 0? Yeah, so those of you in methods would know that it's, or who have done methods would know that it is undefined. All right, it doesn't exist, it can't exist because you cannot divide by 0. So, therefore, I would call it, well, so not 0, I would write undefined. So if you ever see a line going straight up and down, you can know straight away that is an undefined line. It cannot have a gradient. It is impossible because you cannot divide by 0. There is no change in the x values. All right, it is impossible to have a gradient. You try and do that in your calculator, it will break. All right, so this is everything you should be able to, everything you should need to do 6B out of your textbook. Again, the textbook PDF is up on Compass for you all.